What up, everybody? Welcome to another episode of Ask Paul. My name is Paul Abernathy, your host, as always, and welcome to the podcast where we try to answer the questions that you, the general public, and electrical professionals at large, submit to us at paulabernathy.com, and I answer them via email, or if you're one of the select few, I answer on a podcast. So if you want to hear our show or you want to hear other shows that are very similar, maybe you just stumbled across this and you're thinking, what other options are there out there? What other shows to listen to? I encourage you to go check out Electrician Live Broadcast Network, and you'll see that we have an Electrify show there, which is kind of like a Joe Rogan-esque type of show where you can watch the video or you can just listen to podcasts. We also have, obviously, the Ask Paul is there, as well as Master the NEC. And we're going to have other educators and other platforms there in the future, so we can give you a broader listening option, as well as viewing option if you're into the podcast and videocast concept. But go check that out. But again, for anybody out there that has electrical code questions or wants me to go into certain details of certain things, remember, you can always go, and I don't know if once is actually a word, but you can go over to paulabernathy.com. It's paulabernathy.com, and we have a very simple portal there that you can submit your questions and get your questions answered, again, via email, or if it's selected, it will be used in a podcast. And that's what we got today. So again, all of this sponsored by Electrical Code Academy Incorporated. And also remind you, if you want any of our swag, our shirts, our Electrify logo things, hats, beanies, whatever, go check out Electrician Pride. That's electricianpride.com. We appreciate all your patronage over on our shopping network. All right, so in today's episode, we're going to be looking at a question that was submitted, but in looking at this question, I'm probably going to go much, much deeper than what this person wants as far as a response. And that's okay, because I do want to take the opportunity to expand on what actually took place as far as how this is going to be addressed for other people who are installing an application like what this person is asking. So I'm going to read the question, try to answer the question, and then I'm going to go a little deeper in this aspect of it. So here's what's asked. It says, "Good evening, Paul. Just need some clarification for manual transfer switches on a dwelling." Okay. Looking at a job that a manual transfer switch got added, it is between the meter box in the main service panel for the house. Okay, so we has a meter, they added a manual transfer, and then they've got the existing panel that's in the house. Okay, it says the transfer switch is rated for service equipment. It is required to have fuse protection within it to protect the main service panel or main disconnect breaker enclosure ahead of the new manual transfer switch? Thank you for your help. All right, I'm a little confused with the question, just to be honest with you, because I didn't gather in the explanation that there was anything ahead of it. There was just, the installation was basically the meter enclosure, and then they put a manual transfer switch in, and then it feeds a panel. All right. So that's the first part that I, got with that. First of all, you can have the transfer switch on the supply side, 230.82, and you have option 6, which is talking about PV, fuel cells, wind electric systems, energy storage systems, or interconnected electric power production sources, such as a generator. It says, if provided with the disconnecting means listed as suitable for use as service equipment, sounds like it does, and the overcurrent protection as specified in Part 7 of Article 230. So Part 7 is where it talks about the overcurrent protection, and I would think that that's inherent inside of this actual manual transfer switch. Now, what that also tells me that it's possible, the reason he's asking this question is because it is also being utilized as the emergency disconnect outside under 230.85, and in this case, probably going to be used as item 3, which is the other listed disconnecting switch or circuit breaker on the supply side of each service disconnect that is suitable for use as service equipment, which is what he described, and mark the following. It's going to have marked on there emergency disconnect, and not service equipment. And of course, all the markings have to meet 110.21b as well as for sizing and everything like that, and being able to withstand the environment to which it's installed and all that kind of stuff. So at the end of the day, that kind of sounds like what's going on, but is not without the realm to say that what could also go on is that transfer switch could also be service rated, and it becomes the new service. And now what you have downstream is a remote distribution panel. So they could have changed out everything. If that is a SUSE rated manual transfer switch, and then everything downstream becomes 4 conductors, and you separate your equipment grounds and your grounded conductors on the load side of that new service disconnecting means. Okay. And then of course, then that service disconnecting means would meet the emergency disconnect requirements of 230.85 by meeting item number 1, which means that becomes the service disconnect, and then you mark it as an emergency disconnect as well as mark it as a service disconnect. So there's multiple ways that you could have tackled this. Okay. And so I'm not really sure what took place from the manual transfer switch to the actual service panel. But you still have all the rules that you have to have for the service equipment. Still have to have all those rules. And obviously, since you have to meet the requirements of 230.90 when it comes to that manual transfer switch, because of the rules we read, that says that each ungrounded circuit conductor shall have overload protection. So it would be inherent in that manual transfer switch. Okay, so we have to assume that it would be inherent in that. But that's not where I want to go beyond that. So that answers kind of that question. And other things can come into play if you do turn that manual transfer switch into the service disconnecting means. Then you would separate your grounded and grounding or equipment grounds downstream, but then you would have to reroute where your grounding electrode conductor is and how it gets to the electrodes and all that stuff. And it becomes way more complicated. So a lot of people will put this switch in, utilize 230.82. They'll utilize item number 6. They'll make sure that transfer switch is service rated. But again, it's still being used as simple disconnect switch, that type of scenario. But we got to go deeper than this, because there was some changes in the 2020 edition of the National Electrical Code that we want to kind of look at. And so I'm going to kind of look at each one of these and talk about it. And it has to do with Article 705. And I hate when people do that too. I did it too. I always do that. 705. It's 705. Don't you ever hate that? I mean, we all know what it is, but where's O in the number sequence? It's not. So 705 article, and that is interconnected systems. And so we're going to look at that a little bit and do a little bit of a an overview so that it can help other people as well moving forward, because then there was pretty much for years, it was pretty complicated when you made supply side connections. We weren't sure when you had other power production systems added and you were making a direct connection to service conductors, which we see all the time on the supply side. And of course, this permits you to do it in 230.82. So people didn't know, how do you size the conductors? What are they called? How do you route them? What other issues did you need clarification on when it came to making those connections on the supply side? Well, the good news is in the 2020 edition of the National Electrical Code, we do get some guidance. And so we're going to talk about 705 and what guidance it gives, because again, you do have interconnected power systems. In this case, it sounds like he's doing a generator. And again, we're not talking cord and plug. Sounds like this is a permanently installed generator with the manual transfer. Okay. So in this case, you do have to pay attention to 705, right? And we won't get into the 445.18. I'm not sure yet. We'll see how we get there, but that's a disconnecting, or you have an A and a B, which means the power mover that you would shut that down, and that could meet the disconnecting or the emergency disconnect. Very similar to 230.85, but for generators, probably going to be covered in a different episode, because I'm not sure that's what the submitter is really going for. But again, I feel free. That's the beautiful thing about the Ask Paul platform, is that if you want to elaborate and go deeper on your question, just go back to the platform and say, I want to follow up on a question that I ask, and go a little deeper, and I will go deeper. Okay. So that's the beautiful thing about the platform. Okay. All right. So let's kind of look at some things. So if you got your code book, first thing that I'm going to look to is what all's really changed when it comes to this. So I'm going to go to 705, which is interconnected electric power production sources. And we're obviously going to read the scope because if we don't know the scope, we don't know what's applicable here. It says the scope, which is dot 1 in part 1, says this article covers installation of a one or more electric power production sources operating in parallel with a primary source of electricity. So it's operating parallel with a utility. Utility goes off, manual transfer, you switch it on, and now you've got your power production source. In this case, just say a generator. Could be PV, it could be flywheel. There's other options. So this rule 705 covers a broader scope. Okay. But then we got the premise of what's going on here. Okay. So there's this interconnection, but remember, we're talking about connections now for supply side connections. That's why we're going to be in 705.11 to start with. That's where we're going to be. Okay. So if you look in your National Electrical Code book, for those that are following along, those that like to follow along, pause the podcast and get your code book out, go look it up. 705.11 says supply side source connections. So we're dealing with these connections that are on the supply side of your service disconnecting means. Here's what 705.11 says as its core. It says the electric power production source, in this case we'll say the generator, where connected on the supply side of the service disconnecting means, as permitted in 230.82.6, which we previously covered, shall comply with 705.11a through E. So we have A, B, C, D, and E, and you'll notice in your code book, if you're in the 2020 edition, there has a little N in the margin, and that means that these are brand new. So we've had clarification in the 2020. Okay. What are these conductors? What do we do with them? Okay. All right. So when we look at it, let's kind of follow along. So the first one we're going to look at is obviously 705.11. And what does this do? Well, it establishes clear requirements for this circuit, this connection. Now, 705.11a is similar again for the requirements. It says that the continuous output current of all power sources connected to the service may not exceed the rating of the service. So that's important. So the first part is whatever you connect on the supply side of the service, it cannot exceed the rating of the service itself. And the service rating is based on whatever the device is rated at for the service, right? It's a 600 amp service, 600 amp rated device. You with me? 400 amp service, 400 amp rated device. All right, so that's what we got. So that sets the tone, right? That's the output. Next, it goes on to B, and it gives us very significant rules here for conductor sizing from the source of the parallel power production system. Okay. So, or the power source, I should say. Probably shouldn't say parallel. So that's coming in. So conductors, very specific on the conductor sizing and how they are installed. Now, these conductors from the connected point on the service conductors, where you make that point, to the first overcurrent device on the power source output circuit, that means coming from the generator, that's coming back in to the actual dwelling, if you will. Okay. That is what's called your power output source output circuit, coming from the source, okay? Not the utility, from the actual generator, okay? And so it says that conductor shall be sized in accordance with the new section 705.28, and in no case smaller than 6 AWG copper or 4 AWG aluminum. So you're going to have to do the load calc. You got to know what your loads are going to be, what your generator can handle, right? What loads are going to be transferred, and those conductors at any rate cannot be smaller than 6 copper or 4 aluminum. Chances are they're going to be larger than that, but they can't be smaller. So we have a kind of a stopgap that's telling you it can't be smaller than that. It says these conductors shall be installed in accordance with 230.30 or 230.43. So you have to meet rules and requirements as if these were service conductors, and that's why it's making reference there, even though these are not service conductors, okay? But it's giving you, so rather than be redundant and repeat things, it's saying, okay, we're going to send you back to certain sections and you're going to follow those rules as if those were applicable to this installation, okay? All right. So we're over with that. So that starts us on that little bit of a journey. And again, I've already answered the question, I think, for the submitter. If not, please feel free to clarify and send me something else. And a little more detail on your install. But in this case, we're kind of looking at something new when it comes to those supply side connections, because again, that's kind of what's being done in the example, and I'm using it as an opportunity to elaborate. All right, so the next thing let's go on and jump up to 705.28, and this is for sizing, circuit sizing, and current. Okay, so we're going to be looking at that in this portion. Okay, current rules and sizing is very similar, so we're not going to confuse you. It's very similar to what we do with branch circuits, feeders, and services, where we typically do 125% of the continuous load and 100% of the non-continuous load. It says a little different here because current is really based on the output, okay, of the power source, the ability for it to what it can put out. So let's kind of read this rule and see. We're moving now into these conductor sizing. So the conductors that are connecting to the service conductors from whatever our power source was. And here's what the code says. 705.28a says calculations of maximum current, circuit current. It says, where not elsewhere required or permitted in this code, the maximum current for the circuit shall be the continuous output current rating of the power production equipment. So we're going to look at the equipment, and the equipment is going to dictate this. Again, it's the maximum current as a continuous rated maximum power output of the power production source. So you have to look at the source. You have to look at the nameplates of the source. Get this information. Okay. Now, as we go on a little further, let's look at B. Now, B is talking about conductor ampacities. And this is where you're going to be pretty familiar. You've done this before. It looks different, but you've done it. You've been there. So here's what it says. Conductor ampacity. Where not elsewhere required or permitted by this code, says the circuit conductors shall be sized to carry not less than the largest of the following. So I have one, I have a two, I have a three. Number one says the maximum current in 705.28a, which again is based on what the output is of the power source. And you take, it says multiplied by 125% without adjustment of correction factors. So even if adjustment and correctors are in play, you don't do this. And this is very similar. We've done this before. Now, this language is a little bit more straightforward than what you would get for branch circuits and feeders, because you have to understand that you have the first one you do is 125% for continuous and 100% for non-continuous. And then you compare that. If there are adjustment and corrections, you'll compare that to the condition of use and make sure that your conductor can actually handle the actual load after those adjustment and corrections have been applied. And a lot of people get that confused. The 125% now is off the table if you're going with the second option, right? And whichever is larger or results in the larger conductor, that's what you use. So that's what we've done for feeders. That's what we've done for branch circuits. So this is similar, but it actually words it a little cleaner. So kudos to the code panel here, because here's what it says. Again, it's the maximum currents in 705.28a, okay, multiplied by 125% without adjustment and correction factors. So you're going to take whatever the max continuous output current rating that is on that piece of equipment, that power source, you're going to multiply that by 125%, right? So that's one option. The next one says again, whichever results in the largest conductors. The next one says the maximum currents in 705.28a with adjustments and correction factors. Okay. So then the third says where connected to feeders is smaller than the feeder conductors, the ampacity is calculated in 240.21b based on the overcurrent device protecting the feeders. So that's like a tap rule for a feeder tap. Okay, and that's where you get 240.21b. So the takeaway here, or the most important takeaway here, is that the maximum current as a continuous rated maximum power output of the power production source generator is what you're going to be using in A. It also establishes that the requirements for the minimum conductor ampacity be based on 125% of the maximum current or 100% of the maximum current after the application and conditions of use, whichever is greater. So in this case, you can take the conductors at a higher rating. If they're rated for 90, let's say, you do your adjustment and corrections, and you have to make sure that your conductors can at least handle 100% of whatever the maximum current output is of your power source after adjustment and correction purposes. Okay, so whichever one of those resorts to a larger conductor, that's what you're going to use. If that confuses you, again, go back and re-listen to it. Really, what it's saying is the very same thing you do with branch circuits, for example. If you have continuous loads, then you would take it at 125% of the continuous loads and 100% of the non-continuous loads and size your conductor. Then, if adjustment and corrections are to take place, then you're going to size your conductor. At that point, you can use the 90 to adjustment and corrections as long as the resulting conductor ampacity is still adequate to handle the actual load. And that's the same thing you're doing here. After adjustment and correction, you need to make sure the conductor is adequate to handle the actual what? Maximum current output of that actual power source. If that's the case, and it does, whichever one of those options resulted in the larger conductor as a result of that calculation, that's the one you choose. Okay? So it's essentially the exact same thing, just kind of worded a little different. With me? Okay. So that's that part of it. And that's about as deep we'll go into that. So now we want to backtrack again. Now we want to head on back because we dealt with the conductor thing. We want to head on back and let's get back to 705.11 and let's kind of go a little bit more on that one. So the next thing we would look at in that one is we covered it is 705.11. B. We want to finish that last portion of it that I talked about earlier, that piece that talks about the conductors installed in accordance with 230.30 and 230.43. Because again, these aren't service conductors, but it makes a reference to it. So we want to clarify, okay? So that's something we want to make sure that we touch on before we even move on to C and get to the overcurrent protection requirements, okay? So let's kind of dig into this one. And to be honest with you, we kind of covered it, but we might have just, skimmed over it to the point where you're like, okay, I know he said some reference to services, and what did that mean? Basically, all this is saying is from the connection to the service conductors up to the first overcurrent protective device, and we're going to get to that in a second. Those conductors between those points, they're connected to service conductors. And so all it's saying is, remember that when you're doing that requires that these conductors be installed in accordance with 230.30, which is dealing with underground service entrance conductors and the rules associated with 230.30, or 230.43, which is dealing with the wiring methods for service conductors where they're 1,000 volts or less. So while these power production source outputs, again, it's the output coming from, again, playing with those words, inputs, outputs, sources, and all that, it's what's coming out of the generator that's going to feed back into the system, because obviously it doesn't matter what we feed to the generator because it's irrelevant. It's what's coming out of the generator. So that is the output of the generator or the power source. Those conductors, they're not service entrance conductors. Obviously, you never have a service conductors with a generator, okay? They're feeders. However, this is an example where they're telling you you're going to treat them like service entrance conductors as far as your installation. You're going to treat them as such. So it's a good rule because it's telling you, look, the same characteristics, the same potential for hazard, because of the nature of their connection up to their overcurrent protected device, they very much act just like service entrance conductors, even though they are not. Now, theoretically, they connect, so they act like it, but they are not technically service entrance conductors at that point because they are part of the output that's feeding into the system, right? But at the end of the day, just, because this could be from a PV, not just talking generator, but this could be from a PV application, wind generation, other different options, okay? So it's just reminding you to meet these rules, okay? So they're not calling those service entrance conductors. Again, those are power production source output conductors, but you're going to be very much treated all the way up to that first overcurrent device between the generator and the connection to the supply side of the service, you're going to be treating those as power production source output conductors, but the code says you treat them like they're service entrance conductors and follow the rules in 230.30 or 230.43. Okay, whichever one's applicable to your installation. Okay, you get me? All right. All right, and it makes sense, right? Because of where they're being connected onto, right? They're basically service conductors, right? This is the way they are. Now, they might be smaller because, again, as we talked about, they have to be sized to minimum, and they got to be sized actually to the maximum output. And we just covered the sizing rules. They might not necessarily be the same size as the service conductors that they're connecting onto. Those aren't taps, though, by the way, in general. But what is interesting is, like I said, the reference that I gave you in 705.28 to the feeder tap rules and those type of rules that could be applicable if you use one of those options. Okay? Anyway, that gets way deeper than we need to go, and I don't want to have a million heads blow up and get confused. So let's keep going. So next thing we're going to look at is 705.11c, and this is the overcurrent protection. This is what people ask a lot of questions about at this point. What is the rule here? Okay, so when we look at this one, this is talking again about overcurrent protection, and it's kind of a weird way that this rambles on. A lot of this stuff in 705.11c was previously in 705.30. There was a revision to 705.30. If you go look at that, you'll see that it's all grayed out. So there's some things that were removed and kind of tried to integrate here into this new section here, or subdivision here. So we got to kind of wrap our head around it a little bit when it comes to this. But the biggest thing is obviously overcurrent protection for these conductors are required. And 705.30 is going to give you the rules for that. One of the biggest takeaways from here that people ask is, okay, so I make that connection to those service conductors. How far can I go without, ending up into an overcurrent protected device, right? And so you need to read 705.30. We'll kind of take a glance at it. But the biggest picture here was, how far can I go, all right? So when you review the details that are in 705.11c, you'll notice that it gives a various length allowances for the length that these conductors can go from that connection to those service conductors, right? It's varying length. For example, number 1 says with overcurrent device located within 10 feet, okay, within 10 feet of the conductor length in dwelling units and 16.5 feet in other than dwelling units with the point of connection to the service. Okay, so if I've got overcurrent devices located, again, within 10 feet of the conductor's length, okay, so whatever the length is, but I put in an overcurrent protected device within 10 feet when dealing with a dwelling unit and within 16.5 feet in other than a dwelling unit from that point of connection to the service, then again, it's going to be that where do I put this overcurrent protection? It's at the 10 feet or less. Or if you're dealing with other than dwelling, I can go up to 16.5 feet or less. Okay? And that is if I put in overcurrent device and where it's located specifically in that circuit, because it's got to be there. But where do you put it? And what's interesting is we have a number 2. And a number 2 says in other than dwelling units. Okay? So other than dwelling units with an overcurrent device located within 71 feet. That's a weird number. I am more than sure they had a reason for the 71 feet. I don't know why. Somebody out there smarter than me knows there's probably a reason. Why didn't they use 70? Why is it 71? I know who would know. John Wiles. I'm sure he would know. I'm sure that Bill Brooks would know. I do not know why that number was there, but it is what it is. It's in the code. And of course, you could go back and look at the TerraView. You could probably look at the submittals. You could probably read it and probably dissect that, which is a good time to remind you to go listen to a podcast that I did previously, or it might be a video. I can't remember what I did. I think it's a video where it was a video where I used it to determine unsupported raceways and where the code changed and how you dissect it and use the old additions, the ROPs, the ROCs, and find out why the code did what it did. You could do the same thing for this. You could go back and look and see what was the substantiation in order for these numbers. And hopefully it's there somewhere. because these are numbers, 71 feet. Where'd that come from? All right, again, so I'm sure it is the distance, impedance, and all this kind of stuff, and that happened to be the distance, and I'm sure there's more to the story with that. Okay, anyway, it says in other than dwelling units, says with an overcurrent device located within 71 feet of conductor's length from the point of connection to the service. Okay, so we're making a supply side connection. It says provided that cable limiters installed in the ungrounded conductors are located within 16.5 feet of conductor's length from the point of connection to service. So this is installing what's called cable limiters. Okay. Now, typically cable limiters are not marked as overcurrent protected devices. They're not fully rated, but they will limit the level of current. So provided you install these properly, and again, I probably would say not the option I would do on an AC disconnect or this connection. I'd probably put typical overcurrent protected devices in there and roll with it within those distances. But this does allow you to go up to 71 feet, okay, before you get to your overcurrent protection if you use cable limiters, right? So again, this is the use of those applications, okay? Okay. Let's see here. Other questions that people may ask. Let's go back to C real quick and read the whole gist of C. It says the power source output circuit conductors, again, that's in our case coming from the generator, could come from the PV, whatever, but that's what we're talking about, shall be protected from overcurrent in accordance with 705.30. Okay. And then let's see here. It also reminds us, it says where the power source output circuit conductors make their connections to the service outside of a building. Okay. So this is outside of a building. So it's making those connections outside. They shall be protected by overcurrent devices in a readily accessible location outside the building or at the first readily accessible location where the power source conductors enter to the building. So that's very similar to what you'd have in 230.70A where it's outside or nearest point of entry. Okay, again, there you go. So you have to have that protection, and it gives you some rules. Now, it also goes on to say where the power source output circuit conductors make their connection to the service inside of a building. Okay, so a totally different thing here. Where it makes it inside of a building, they shall be protected by one of the following methods. So what I read you earlier has to do with the dwellings and within 10 feet and all this stuff. That's for inside of the dwelling. For outside of the dwelling, then you would make the connection outside. And okay, they shall be protected by overcurrent devices in a ready accessible location outside of the building or again to the nearest point of entry. But there's two different issues here. One is the connection outside. And these rules that I just read you about the 10 foot and the 16.5 foot or up to 7 foot, that's for when the connection to the service conductors are made inside of the building. So there's a different condition when it's made outside of the building versus what's inside the building. So outside of the building, there's no really conductor limitation. The length is not limited. You wrap it around the building if you want. But if you're going to make that connection inside of the building, then again, because of the nature of these conductors and the limiting the length, I mean, essentially we determined these weren't service conductors, but you treat them as such. We obviously want to limit the length inside of a building. And if you're going to be longer, then you're going to put in there the cable limiters if you're in an other than dwelling application. But why would you go through that? Just put an overcurrent device, follow the rules anyway, and don't worry about limiters. Just put in basically your overcurrent protective where you're going to have your AC disconnect anyway. So probably not going to install the limiters. And I don't know a lot of people that are going to use the 71 foot application in other than dwelling applications, but I mean, it's here. But just remember, that's for indoor connections. Outdoor connections, follow the rules in the midpoint of C. And again, doesn't matter the length. Just make sure once it penetrates inside the building. And once it penetrates in, and then it goes right into the overcurrent protected device. Okay. Okay. So that's that part of it. If I haven't confused you by now, might have, and that's okay. All you educators out there that say, Paul, you could have done a better job at that. Eagerly await your podcast. Eagerly await for you to put your name out on the line and create a video. Don't just talk the talk, do the walk. All right. Everybody's a critic until they want to put it in print, or they want to put it on a podcast or a video, right? Especially when you're trying to convey something on a podcast without the mental picture. It sometimes can make it difficult. All right. So the next thing we'll look at is the connections that is new to 705.11, and that is D, connections, right? So 705.11D establishes the requirements for connections, and we're going to dig into these so that you understand these in a little more detail. Okay, these connections, let's read what the code says, and I'll give you kind of a summary. It says the connections of the power source output conductors, circuit conductors, again, coming from the generator or from the PV to the connection to the service conductors on the supply side, as we've already established is permitted. It says, shall be made using listed connectors as described in 110.14 and comply with all enclosure field requirements. So remember, this can be a big deal if you're going into an enclosure that's existing and you're going to now make these connections. You got to remember that the enclosures and things have fill requirements, okay? So you have these fill requirements enclosures in 312 that you have to be aware of, and you have space issues in panel boards and where you make these connections. So be very aware. Not going to go into those details on this podcast, but just make sure you do that and that you know that you actually have adequate space to be able to make this. The other thing to remember is that you're tapping, even though we don't call these tap conductors or tap rules apply. Essentially they have their own kind of like tap rules, and we just discussed that in 705.28 and all that kind of stuff. But essentially what you want to do is remember that when you make these connections, whatever device you use, or whether you're doing a splice box or a tapping device or one that pierces, whatever you're using, you want to make sure, one, that it's suitable for use with service entrance conductors. That's key, all right? Also, these will come with the manufacturer's instructions. It's very important how you connect these and follow their instructions. 110.3b, they're going to be there, right? And if not, and somebody just gives you this tapping device, you need to reach out to the manufacturer and see if there is anything that you need to be aware of. It might be just simply cut and dry what you do with it, but remember, it should come with instructions. It should have information. The problem with supply houses sometimes just throw things out of a box, and the box, you don't get to see all the instructions, okay? So these are going to be listed, and you're going to have to follow the manufacturer's instructions. Remember, instructions are part of a listing, right? Okay. And of course, if you remember that you have tap blocks, if you have blocks that power distribution blocks, and you're going to use them with service equipment, then your service entrance conductors, then they have to be rated as such, okay? All right. Anyhow, that's the first thing you want to do. And again, you want to make sure that there's enough available space in your existing enclosure to be able to make this connection, okay? That's critical. And that's really what this is saying here. Now, it also goes on to say, any modifications to existing equipment shall be made in accordance with the manufacturer's instructions, or the modification must be evaluated for the application and have a field label applied. So field label is evaluating body. You have these, UL I think has a field evaluating body. You have ETL does this. A bunch of them will come out and do a field evaluation if there's some modification or whatnot to be able to make this connection. But typically you're going to use products, and you're going to use listed products, and you're going to make it. But just be aware that if you're not using the manufacturer instructions or some modification must take place, then it might be where an AHJ requires that you have a field evaluation to make sure this is okay for what you're intended to do it. It also says for meter socket enclosures or other equipment under the exclusive control of the electric utility, so connections made inside of the meter. You as an electrician might have installed that meter, but the moment that it's installed, the moment that tag is placed on it, it becomes their exclusive control. Obviously, if the utility laterals are coming up into it or overheads are coming into it, and it's theirs. But again, you could have some tenant side applications where it's not theirs and it's not under their exclusive control. Anyway, only connections approved by the electric utility shall be permitted in those that are, so be aware of that, those that are under the exclusive control, and you want to make a connection in there on the supply side, Make sure you're following their instructions for their piece of equipment and how you would make those connections. I wouldn't assume anything. Don't have a problem picking up the phone and calling somebody. Okay? Call a utility. Just be clear. It only takes a second. We want to make sure you do it right. Okay. The next thing we're going to look at in this out is looking at E. And E is ground fault protection. So we're going to look at that, and that is, again, you see the ends here. So that's adding. So we're talking about, again, supply side connections. So what does that rule say? Well, it's pretty straightforward. It's basically telling you, and it does verbatim. Let's kind of read it, and you'll get it. It says, for connections rated, I'm not sure what the spacing issue is here with the NEC. I guess it's a typographical thing. It says, because again, they're mainly focusing on connections here. For connections rated 1,000 amperes or more to solidly grounded Y service exceeding 150 volts to ground, but not exceeding 1,000 volts phase to phase. So those are your criteria, okay? So it establishes the requirement for GFP, and it simplifies it, and it says, look, if your power production sources connections are made to a solidly grounded Y service, and it exceeds 150 volts to ground, but does not exceed 1,000 volts phase to phase, then GFP, meeting the requirements of 230.95, must be followed. That's what it's saying, verbatim. And of course, you got the rules in 230.95 that you would follow under that situation, right? Seems pretty straightforward to this point. Now the only thing that ends up kind of coming to mind at that point is you're thinking, well, wait a minute. If it meets this criteria, isn't there already GFP on this service? Because that's what 230.95 is dictating, right? And it's already appears in the supply side section of the code when it comes to 230. That's 230.95. So that's already in place. You're thinking, well, that's kind of already there. So if you have an existing service and you're doing this and there's an existing GFP and it's on the main service, shouldn't that provide GFP for both that utility as well as the power production without any need for any additional equipment? Okay, that's something you're going to have to discuss with your AHJ. All we can tell you is what this says. This says that for connections rated 1,000 amperes or more to a solidly grounded Y service exceeding 150 volts to ground, but not exceeding 1,000 volts phase to phase, ground fault protection meeting the requirements of 230.95 shall be provided. So you might be able to argue the point that it is already provided at the utility, because again, this is taking place on the supply side of the service. So typically in 230.95 anyway, if you met this criteria, then you had to have GFP. So isn't it kind of already there? Anyway, so we'll let you argue that with your AHJ, because I certainly don't want to put two in. They're not cheap, but you get the point. So anyway, that was kind of what we wanted to cover today as a kind of just an overall picture of what's changed with the 2020 and these connections on the supply side. Yes, they're permitted. Circling back to the original submitter's question, to me, it just sounds like he's got a meter, a transfer switch manual, and a panel, and he's trying to determine, depending on his install, whether or not that transfer switch is just being used as a disconnect, and it still has a breaker in there. Is it being used as service equipment when it comes to downstream panels having to now separate their grounds and neutrals? Or is it being used simply as a disconnecting means of meeting the emergency disconnect requirement, still SUSY rated as stated and marked as such, and now going downstream, it goes to an existing service panel, and that's his installation there. So there's two different ways to look at it, but what I wanted to do is dig a little deeper when it came to the changes that have to be made to the supply side. So hopefully that brings a little more insight overall to the question and at least makes you think about it. And I encourage you to, if you have any follow-up questions, feel free to go to paulabernathy.com and submit those questions. We can dig deeper into this and kind of touch on things that maybe wasn't clear for you. And feel free to do that. Until next time, folks, stay safe. God bless.